At the beginning there were just massive clouds of dust and gas, which started to get pulled together by gravity. The closer and denser these cloud particles got, the stronger the pressure got. And when the pressure increases, so does the temperature. The temperature increases until it reaches the correct amount for nuclear fusion to happen within the star's core. Nuclear fusion is the power that keeps the star alive, depending on how much mass the star has to fuel its fusion reaction. This decides how long each star is going to live.
A star is a luminous sphere of plasma held together by its own gravity. For at least a portion of its life, the star shines due to the nuclear fusion of hydrogen into helium in its core, releasing energy that traverses the star's interior and then radiates into outer space. Even though it is constantly exploding in a nuclear reaction, the Sun and other stars are so large and have so much matter in them that it will take billions of years for the explosion to use all the fuel in the star.
When stars die, there are a number of scenarios which can occur depending on the star's mass. When a star dies, it is because the outward pressure and the fusion of hydrogen into helium is no longer balanced with the gravitational force of the outside layers of the star acting inwards. When the star starts running out of hydrogen, the forces become imbalanced and the core begins to collapse.
A star of the same mass as that of our Sun is relatively small in comparison to others. First, it will swell up to become a red giant before becoming a planetary nebula, which is an expanding cloud of interstellar dust and ionized gas released from a red giant in the form of a bright cloud. After this stage, the cloud collapses again, becoming a white dwarf, which is a glowing white star. Enough fusion is still occurring in the core to keep the gravitational force from collapsing in on it. Slowly but surely, the star will run out of hydrogen altogether and will cool down. The theory of the next stage is that the star cools to the temperature of the cosmic microwave background and therefore is not visible. They are purely theoretical.
For stars which are between 1.5 and 3 solar masses, where one solar mass is the mass of the Sun, the star again swells to a red giant as hydrogen fusion moves past the corona, which is one of the most outermost layers of the Sun, and causes the star to grow in size. Because the star is so massive, the gravitational pressure inwards is huge, and when the outwards pressure starts decreasing, the star does something incredible. The collapse of the core releases such huge gravitational potential energy that a massive explosion is created. Due to the massive mass of the star, this explosion can often leave a concentrated star behind, called a neutron star, normally about only 7 ions in diameter. These stars are made almost entirely of neutrons and are extremely hot.
Our type of star has a mass over 20 times that of the Sun. It first swells to a red giant, and then because it has so much mass, it explodes into a supernova. If after the supernova the core still has a mass of over 2.5 times the Sun, it will collapse completely into a black hole because there is no known force to counteract the gravity pushing inwards. This is a theoretical point which is said to have zero volume, infinite density, and is called a singularity. Its gravitational pull is so strong that anything wishing to escape would have to travel faster than the speed of light to do so. Thus, the hole is black due to the fact that not even light can escape. Anything which travels beyond the event horizon is in a completely unknown territory to us. Scientists can only now imagine what might happen beyond these points. Perhaps they join up with a different point in space altogether, creating the famous Einstein-Rosenberg bridge, and proving time travel could exist. Perhaps they lead to an alternate universe altogether.
Schwarzschild radius is the radius in which a body is so dense that its escape velocity is equal to the speed of light. Any body that is smaller than its Schwarzschild radius is called a black hole, so named because the escape velocity is higher than the speed of light, meaning that light passing close past a certain boundary, known as the event horizon. When an object turns into a black hole, the radius of its event horizon is equal to its Schwarzschild radius, and is a boundary at which nothing, not even light, can escape.
We've been together for about...
Hi, my name is Cameron.
I've also got a problem with their glue. what can we do? No.
It's just
It actually has.
Right, I'm in the right spot. The G spot.